Okay, so concept number 3 would be to have a function per se. Concept would be determine the derivative to f of x equals, I don't know, we did a whole bunch of them. The algebra you're going to have to look up, but the algebra is not a concept idea. The algebra is practice. So maybe I want to come up with the derivative to x squared plus x minus 1. There you go. So by definition, the derivative is going to be given by, so if that's f of x, I can use Newton's notation. Okay. This is Newton's notation. Or I could use Leibniz's notation, which would say this part is the part that says take the derivative. So this says take the derivative of f of x. Okay? Either way, over here, you know that the definition of the derivative is h approaches 0 of the difference quotient. That is the derivative. That will give you the slope of the tangent anywhere to this function. And that is, by definition, the derivative. So you can't get all upset over the different words, okay? Derivative means the slope of the tangent anywhere. Hold on there. I was just taking a sip of my coffee. Okay, so what have we got here? F of x in this particular question, I said, was x squared plus x minus 1. F of x plus h, therefore, will be x plus h squared plus x plus h minus 1. So, looking at that, if I'm going to plug it into this, it's going to be the limit as h approaches 0 of f of x plus h, so it's going to be x plus h squared plus x plus h minus 1, subtract f of x, so it's x squared plus x minus 1. Brackets are your friends, use them, over top of h. So limit as h approaches 0 of x squared plus 2xh plus h squared plus x plus h minus 1 minus x squared minus x plus 1, all over top of h. So I've got x squared here, and I've got x squared there. I've got 2xh. I've got h squared. I've got an x. I got a minus x. I got a 1. I got a minus 1. So I guess that's going to leave us with the limit as h approaches 0 of 2xh plus h squared plus h over top of h. We want to common factor out that h value. So it's the limit as h approaches 0. 2x plus h plus 1 over top of h. You'll notice that they will now reduce, and we can do that since h does not equal 0. Now, you will notice from today's work, I need to move up a bit, I'm sorry. You will notice from today's work that if we tried to put the limit in here, we'll get 0, 0, 0 over top of 0. We'll get indeterminate form using property number 8. So you're actually working with some of these concepts before you even knew about the limit concepts. So what this comes up with is we have the limit as h approaches 0 of 2x plus h plus 1. We're going to turn the limit on. Ring, ding, 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 ding. Ring, ding, 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 ding. H is going to approach 0. Ring, ding, 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 ding. There are no h's in 2x. Ring, ding, 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 ding. There is an h here. It's going to go to 0. Ring, ding, 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 ding. And then, thank goodness, we're done. And it's 2x plus 1. And that, ladies and gentlemen, is what we call the derivative of f of x. And what it is a function that will give me the slope of the tangent anywhere on the original function. So this is the slope of the tangent to f of x for any x as an element of the real numbers. And so I'm going to stop here, and there you go. We'll do another concept in a minute.